All right, here we go. So this is pronounced L'Hopitals, or sometimes I guess people call it hospital. Uh, but I mean, I guess I call it L'Hopitals. Google it later on, YouTube it, see how they pronounce it. Um, so what is L'Hopitals rule? L'Hopital, the person L'Hopital didn't actually invent L'Hopital's rule. He just came across it in the notes and didn't give. I don't, and then he wrote it in his notes, and then someone looked at his notes and like, oh, we're just gonna call it L'Hopital's rule. But L'Hopital didn't create it. I'm not a history buff. You guys check it out, learn about L'Hopital's rule. Who was the actual creator of L'Hopital's rule? All right, how do we use it? What is L'Hopital's rule? So remember this limit here, and this is actually a perfect activity for because it's most people find this pretty easy, pretty not that it's nothing crazy. So how were we used to do this limit before? Can you do direct substitution? No. So we'd have to do it algebraic manipulation, and then you notice that the numerator is the difference of squares. So limit as x approaches 2, and then this is the difference of squares, so that's going to be x plus 2, x minus 2, all over x minus 2. And what's going to cancel? I have a product and I'm dividing. So yeah, the x minus 2's cancel out. And now can I do direct substitution? Yeah. 2 plus 2 is 4, and that's my limit. With L'Hopital's rule, it states usually you want to do it one at a time, like the numerator and the denominator. You go limit as x approaches 2 of x squared minus 4, that is 0. Then I go limit as x approaches 2 of x minus 2, and that's also 0. So, yeah, but you're not going to say 0 over 0. You're just going to say it's of indeterminate form. Since limit as x approaches 2 of x squared minus 4 over x minus 2 is of indeterminate form, comma, L'Hopitals may be used. L'Hopitals rule states that I can just take limit as x approaches 2, and I can take the derivative of x squared minus 4. What's the derivative of x squared minus 4? 2x over, bless you squared. What's the derivative of x minus 2? And I can just plug in my x approaches 2 and still get the same value. What is 2 times 2? OMG, look at that. Isn't that cool? The derivative of x minus 2 is 1. The derivative of x squared minus 4 is 2x. But that only works if it's of indeterminate form. It has to be indeterminate form. What does that even mean, Chav? What does that mean? Indeterminate form means 0 over 0, infinity over infinity. Those are the two options that we have to worry about. There's also others, infinity minus infinity, because some infinities are bigger than others. There's 1 to the infinity. Sometimes it's 1, sometimes it's not. Relax. These are the only ones we're going to worry about. Cool? That's the only time you can use it. Chav, why does it work? When can I use L'Hopital's rule? Oh, put that in here. We can use L'Hopital's rule when we have a limit that's going to give us 0 over 0 or infinity over infinity. Indeterminate forms. When limits form indeterminate forms, comma, L'Hopital's may be used. Make sure that the function is continuous. Of course, these functions are continuous in this entire domain, so you're fine. Are we okay? Say it again. When do we what? I didn't hear you because you were really silent. What do we do if what? If it's not continuous, oh, well then we can't even take a derivative, right? Because remember that in order for you to take a derivative, you must be continuous. All right, Miss Kyle, let's focus, Miss. Don't worry about that for at least a little bit, please. All right, here's the informal proof. This is above us, so we're not gonna go there. But here it is. Here's the informal proof. It does look like, yeah, that's the definition of a derivative. And so, yeah, and I got this from not the best sources, Wikipedia or something. Here we go. We're just gonna use it. You guys ready? We're gonna go limit as x approaches 0, and we're gonna focus on the numerator, 7x minus sine x. So 7 times 0 minus sine 0, we do in fact get a 0. Let's see what we get in the denominator. Limit as x approaches 0 of x squared plus sine 3x. And we get 0 plus sine 0, so we get a 0. So it is of indeterminate form. And these functions are continuous in this entire domain. So we're going to take a derivative. Limit as x approaches 0, the derivative of 7x is 7. What's the derivative of sine x? So 7 minus cosine x over the derivative of x squared, 2x, and the derivative of sine 3x? Yeah, so 3 cosine 3x. I no longer get 0 over 0 because I see a 7 in the numerator. So limit as x approaches 0 in the numerator is 7 minus cosine of 0 is 1 over 2 times 0 is 0 plus cosine of 0 is 1, and 1 times 3 is 3. Do you guys see what we got there? Okay. 7 minus 1 is 6 divided by 3. And there it is. How do we feel, guys? Feel okay? Oh, you're good. You're good. All right. From the 2016 international exam, they did not give me percentages. You want to give this one a shot? Pretend you don't know that if you have to use LHopitals or not. Obviously, we're going to use LHopitals. Take a 1 minute head start. I did get 0 over 0. I did it here on the side. Limit as x approaches 3 of tan x minus 3 does equal tan 0, and tan 0 is 0. Limit as x approaches 3 of the denominator, 3 to the x minus 3 minus x, is 3 to the 0. Remember that e to the 0 is 1. And so you do get 3 minus 3, which equals 0. So I can use LHopitals. Right? What's the derivative of tan? So I'm going to write secant squared. You got to keep the argument. X minus 3. What's the derivative of 3e to the x minus 3?
3e to the x minus 3.
Yeah, times 1. So it's itself. Minus, what's the derivative of x? 1. It looks like we are done. By the way, if we would have gotten 0 over 0 again, we could have done LHopitals. You can keep doing it as long as it's of indeterminate form. It's no longer indeterminate now. If I plug in a 3 in there, 3 minus 3 is 0. Secant of 0 is 1. Remember, make sure we know that, guys. Secant of 0 is 1. And since it's 1 squared, it's still going to be 1. Remember, the secants are reciprocal cosine. So cosine of 0 is 1, so secant of 0 is also 1. We're okay? Over, I'm going to plug in a 3. 3 minus 3 is 0. That's the exponent. E to the 0 is 1. And 1 times 3 is 3. So I got 3 minus 1. So 1/2. Yes. The numerator? Uh-huh. No. 3 minus 3 is 0. Secant of 0 is 1. You know what I mean?
Yeah.
I guess you could do that, I guess. But 1 squared is still 1, right? All right, how are we feeling, guys? Are you guys ready to do our first free response question from the AP exam? Yeah, look, here's our first one. This is from the 2018 AP exam. So the AP exam that those guys took. We're going to do this one together. And we're going to see how tough this is. And obviously there's some L'Hopital somewhere in here. Let f be the function defined by, and they give me a function. By the way, this one's a no calculator, these questions. Find the average rate of change of f on the interval 0 to pi. Average rate of change. That doesn't sound like calculus. That just means f of pi minus f of 0 divided by pi minus 0. That's all that is. I'm going to go to the side. I'm going to go f of 0, e to the 0 cosine 0. E to the 0 is 1, and cosine of 0 is also 1. So 1 times 1, 1. F of pi, and I'm going slow, bless you. That's e to the pi. You do not know what e to the pi is, so leave it as e to the pi. If you put a decimal, it's going to get flagged, 100%. Cosine pi. Cosine pi is -1. -1 times e to the pi is just negative e to the pi. You don't have a calculator, guys, so do not put any decimals. It'll get flagged if you put a decimal. So here we go. This is going to be, I'm just doing f of pi minus f of 0. Negative e pi minus 1 divided by pi. Leave it alone. If you feel like factoring out a negative, I guess you can, but I wouldn't. I would just leave it like that. Let me go ahead and stretch this. There we go. So that negative doesn't float. How do we feel right now, guys? Okay. What's up? Right there. What is the slope of the line tangent to the graph of f at x equals 3 pi over 2? What do I need to find the slope? Just take a what? A derivative, right? Yeah, let's just say space here, goodness. Take a what? A derivative. What are we taking? A derivative. So here we go. I'm going to write f of x first. F of x equals e to the x cosine x. And if I want to take a derivative of this, what rule do I got to use? Underline e to the x, double underline cosine x. Start a new line. F prime of x equals first times the derivative of the second. What's the derivative of cosine x? Plus the second times the derivative of the first. What's the derivative of the x? You are done. Now you're doing simple arithmetic. Let's see. Before you plug in 3 pi over 2, do you notice how we can probably factor out an e to the x and make life a little simpler maybe? E to the x, parenthesis, and I'm going to put the cosine x first because that one's positive, and I'll put the sine x next, like this. Maybe it's easier, maybe not. We'll see right now. What am I going to plug in? There we go. F prime of 3 pi over 2 equals e to the 3 pi over 2. We have no idea what that number is. Leave it alone. Parenthesis, cosine of 3 pi over 2 minus sine of 3 pi over 2 equals, so a little bit of pre-count, not extreme, and I'll slow down. E to the 3 pi over 2, parenthesis. What is cosine of 3 pi over 2? 0. Minus, what is sine of 3 pi over 2? -1. Minus a negative, that's going to turn into a, so my final answer is just, there you go. And that's the merit. Are we okay, guys? All right. Find the absolute minimum value of f on the interval 0 to 2 pi. We aren't here yet. We aren't here yet, but we're so close. Yeah, that's not. We'll come back to it when we get the experience. Here we go. This is what I wanted to look at. Look what it says. Let g be a differentiable function such that g of pi over 2 equals 0. The graph of g prime, the derivative of g, is shown below. Find the value of limit as x approaches pi over 2 of f of x over g of x, or state that it does not exist. Justify your answer. All right, here we go. I'm going to write limit as x approaches pi over 2 of f of x equals f of pi over 2. Do you already have that? I don't. Let's figure out what that is. Where's my f? Over here. E pi over 2 cosine pi over 2. E pi over 2. Yeah. All this is part of the same question. So that looks like 0. Does everyone know why it's 0? No? Okay. E to the power over 2, some number. I don't know what that number is, but look at this part right here. In the unit circle, pi over 2 is right there at the 90-degree angle, and cosine is 0. And anything times 0 is going to be 0, unless you're in BC calculus, and then you have, well, we'll get there. Yeah, that's an indeterminate form, infinity times 0. Sometimes it's not 0, sometimes it is. Okay. But we're not going to get there. UH does give you those, so maybe we'll talk about them in a little bit maybe we'll do the L'Hopital's UH together like last time. And yeah, they give you hard ones. Okay, so there it is. That's the numerator. Limit as x approaches pi over 2 of g of x. Well, that equals g of pi over 2, and they gave me that. What did they tell me that g of pi over 2 was? Do I have an indeterminate form? Yes. And g is differentiable, so g is continuous. Since g is differentiable, g is continuous on its domain. F is also continuous on its domain. It doesn't need an apostrophe. Period. Okay, one last sentence. Since limit as x approaches pi over 2 of f of x over g of x is of indeterminate form, comma, L'Hopital's may be used. I was there that year when we graded this one. I didn't grade this one, but my roommate did, because they put us in they put 2 per room, and there was chaos when they were grading this one because not everyone put this statement, so they couldn't get their full 9 points. Yeah, that year. What's up?
I thought that. Okay, I think I'm supposed to that because I thought when we had a sharp curve like that at pi over 2.
Notice what that is, though.
That's not
It's g. It is. It's differentiable. I have a derivative. My original curve does not have an abrupt term. G prime prime does. So G prime is not differentiable pi over 2, but G is differentiable. Look, I got a derivative everywhere. Yeah. Do you know what I mean? Okay. All right, here we go, guys. Limit as x approaches pi over 2 is just f prime of x over g prime of x. That's all it is. So let's see what that is. Equals, I already have g prime, but I don't have f prime. Well, I do right here. This is my f prime. This guy right here. So I'm going to write e pi over 2 parenthesis cosine pi over 2. Oh, we already have the answer, right? No, we don't. Cosine pi over 2, well, kind of, minus sine pi over 2 over, and what's g prime of pi over 2? It's right here. This is g prime. 2. Let's see what this is. Bless you. E to the pi over 2, parentheses. What's cosine of pi over 2? 0. Minus what's sine of pi over 2? 1. Just 1. Over 2. So I have a negative. So this is my final answer. I guess you could leave it like that too, by the way. Negative e to the pi over 2 all over 2. There it is. I don't see any mistakes. I think we're good. Let's look at the rubric. This is how the rubric used to come out. It's now a much better rubric, but some of my colleagues actually like this rubric better because they say it's nice and short. Every free response question is worth 9 points. So, Chav, what do I need to do to get a 3? Well, I would like for you to not worry about that, to just worry about getting the best score possible. But if you can get 3 to 4 points per question, you're going to get about a 3. If you can get 5 to 6 points, that's like about a 4. If you can get bigger, more than 7 points, then yeah, you'll probably average a 5. Remember how much it is? Let's see how many points we got. The average rate of change of f on the interval 0 to pi is, did we get this answer? We got a point. Cool? All right, letter B. So letter B, they give you a point for the derivative and a point for the slope. So the letter B is worth 2 points. Did we get the derivative to be this? Ours is even better because we factor it out. But did we get it to be that? We got a point, and we didn't make any mistakes. We factored it out. Ours is better. I like ours better. Cosine x minus sine x. Is that what we had? All right, we got it. And 1 point for a slope. Did we get e to the 3 pi over 2? There we go. We got 2 points. So we're doing pretty good. We got 3. So we're already on this edge. Letter C we didn't do, so we missed out on 3 points. That's fine. Letter D. G is continuous at pi over 2 and limit equals 0. Yeah, we did that. We didn't do it the way they have it, but we did it. We said because G is differentiable, G is continuous on its domain. So we got our point. And then we stated limit as x approaches pi over 2 of f of x is 0. And we stated limit as x approaches pi over 2 of g of x is 0. We stated that right here. See, right there. Bam. Bam. You guys see that? We got it. We got those points. And then look, since g is differentiable, g is continuous in its domain. So we got that point. So check mark. Applies L'Hopital's rule. Let's see. Yep, we applied L'Hopital's rule right there. So we got that point. And did we get this answer? We got it. We got 3. So how many points did we get total? 2, 3, 6. We got 6. 79. Yeah. So we're doing pretty good, guys. There is a note. Look at this note right here. If no limit notation attached to a ratio of derivatives, you get max 1 out of 3. What's up?
So, like show you, like show x equals to f.
Yeah. Later on, you'll have better rubrics, which give a lot of information, more than this. But this is just a breakdown of how the points were done. You know what I mean? How do we feel? Kyle, how do you feel? All right, guys. Now it's just practice time. We took some from Delta, so here are some 2 from Delta, and then we'll set you guys loose. Don't worry, it's a short Delta. I think it's at like 16 minutes or something like that. The graph of the function f shown below, determine the value in simplest form. So first, do this. Limit as x approaches 2 of the numerator. So try to get in good habits, guys. 4x squared plus 8x. Not all of them are going to be needing L'Hopital's. Let's see. Look at this. Do I need L'Hopital's on this? Oh, it says -2. Okay, if I would have said 2, no, but it says -2. 4 times -2 squared plus 8 times -2. -2 squared is 4. 4 times 4 is 16. 8 times -2 is -16. So that's 0. Let's do the denominator. Limit as x approaches -2 of 3f of 3x minus 3. So let's see what that is. 3f of -6 minus 3. This is f right here. So f of -6 is 1. So you get 3 times 1 minus 3. So yep, that's definitely 0 again. Because I get 0 over 0, can I do L'Hopital's? Yes. So I'm just going to go right to it, guys. Limit as x approaches negative 2. What's the derivative of 4x squared plus 8x? 8x all over. Uh-oh. We're just doing chain rule. 3f prime of 3x times the derivative of the inside, 3. So now let's plug in. 8 times negative 2 plus 8 over 3 times 3 is 9. 9 f prime of negative 6. Child, I don't know what to do. So this is actually, you're going to get a little review because there is a graph on tomorrow's test. 8 times negative 2 is negative 16 plus 8 over 9. This f prime of 6, you're just going to find the slope right here. Let's see, that looks like it's 1. Yep. Slope of f. Find the slope of that linear part. So that's it, guys. Negative 8 over 9. That's my limit. That's what that is. Say it again. Well, that's my slope. That's the slope of the curve. Yeah. See how that says f prime is negative 6? So this is f. This is my f. That's what it is. So I just go to negative 6, and remember that derivative means slope. It says 1, 1. All right, guys. Last one. Given selected values of the function f and its derivative in the table below, determine the value of that in simplest form. All right. Again, limit as x approaches 2 of 2x squared minus 8. Let's see what that is. 2 times 2 squared minus 8. 2 squared is 4. 4 times 2 is 8. 8 minus 8 is 0. Yep. Limit as x approaches 2 of 2f of 2x plus x. Let's see. 2f of 2 times 2 is 4 plus 2. F of 4. Here's f of 4. It's negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 2 is 0. It is of indeterminate, and let me wait. I'll wait for you guys to catch up. It is indeterminate. So here we go. Limit as x approaches 2. What's the derivative of 2x squared minus 8? 4x over 2f prime of 2x times 2. Derivative of the outside, leave the inside alone, times the derivative of the inside. Plus, what's the derivative of x? 1. Is everyone okay? All right, let's plug in. 4 times 2 over 2f prime of 4. Oh, 4 on the outside. 2 times 2. Plus 1. I don't see any issues. 8 over f prime of 4 is negative 2. Negative 2 times 4 is negative 8. Negative 8 plus 1. So I see 8 over negative 7.
What happened to the times 2?
Right here. That's a 4. Do you see it? Any questions, guys? Is it pretty straightforward? Yeah, we didn't do any infinities over infinities. Why? Because I prefer to do end behavior with those. When you get to them, you'll see what I mean. Just ask me, and I'll go over there. And that's it, guys. Today's light. Let's take care of the delta. It's only like a 20-minute delta, 15-minute delta. And we'll call it a day.